This invention could be a major breakthrough. According to an international research team, a newly developed material could make it possible for people to travel to other stars. For example, in the case of the star Proxima Centauri. A probe would only need about 20 years for the distance of 4.2 light years. This is to be made possible by using the so-called Aerogel, which is a material that can easily withstand extreme temperature leaps and could thus serve as a laser sail. Find out whether and how a journey to Proxima Centauri will be possible in the near future, now on Clixoom Science Fiction. Here you can watch fascinating science videos uploaded 3 times a week. Subscribe to the channel so you won't miss out on anything. Let's go. 1, 2, 3. Welcome. The properties of the so-called aerogels are simply outstanding. Its fabrics are ultra light and very porous. It is amazing because its material consists of very thin metal or ceramic layers and often of more than 99% of air or free space. Virtually a breath of nothing. These materials are already being used today in real-life applications. For example, silicon oxide aerogels are used in spacesuits. Aerogels also serve as insulating materials. However, up till now, all of these have only been used for special applications, as production is still very complicated and time-consuming. In addition, the aerogels have so far had a major weakness. The material breaks very easily when exposed to large temperature fluctuations. Nevertheless, an international research team has now addressed this exact problem and has done so with great success. The newly developed aerogels consist of more than 99% of air and can even withstand very rapid temperature changes of more than 1000 degrees Celsius. This therefore opens up previously unimaginable possibilities. Initially, the scientists constructed a symmetrical structure from graphene, quite a miraculous substance. These atomically thin carbon layers are the thinnest material in the world, and they are harder than diamond. The research team thus built 2-dimensional layers on which it grew crystalline layers of boron nitride under a protective atmosphere of argon. The graphene was then separated at about 600 degrees Celsius, leaving only the aerogel from the boron nitride layers in an extremely symmetrical arrangement. From the side, this web looks like a kind of spider's web, and the metastructure explains the special properties of the newly developed aerogel. Instead of expanding when heated, it contracts. When the material is stretched mechanically, it becomes thicker in the middle and not thinner. In technical terminology, this is referred to as a negative Poisson's ratio and a negative coefficient of thermal expansion. Xiangfeng Duan, one of the researchers involved, explains, "Our aerogel shows outstanding mechanical and thermal stability for super insulators under extreme conditions." The research team tested the aerogel to its extreme. They heated it up to 1500 degrees Celsius within a very short time. They quickly cooled it down again to minus 198 degrees Celsius. Though under extreme temperature changes, the aerogel structure remained intact, unlike ordinary ceramics, which usually crumble while undergoing the same process. There are other remarkable properties of the aerogel. It has an extremely low density. Can you imagine that? A sample of the aerogel the size of a cube weighs just 1/1000th of a gram. In addition, the material will return to its original shape without pressure, even if it is compressed to a fraction of its size with a press. 3 factors are probably responsible for the material's good insulating properties. On the one hand, tiny gaps in the boron nitride structure hinder heat conduction. On the other hand, the pore walls are reminiscent of a double glazed glass-like windows and therefore provide good insulation. Another point is that the heat conduction in the solid-state material is reduced due to the very low density of the material. In short, the material incorporates some very special properties, and they let the research team develop some blatant visions. Aerogels could revolutionize the exploration of space. Since the material insulates so well, it could be used as heat protection tiles for space transporters, because the air friction when re-entering the Earth's atmosphere causes extreme temperatures, and a probe must also be capable of withstanding a temperature change of several hundred degrees during a rotation in an orbit close to Earth. According to the research team, the aerogel could serve as a material for a laser sail. Based on calculations, a journey to the star Proxima Centauri, 4.2 light years away, would take 20 years. Beyond that, the newly developed aerogel could also be used in automotive engineering. Its strong insulating properties could, for example, protect car components from the high temperatures emanating from catalytic converters. And the material could also prove useful in hydrogen cars, because it could accelerate the reaction in the fuel cell just as well as the expensive platinum currently used. A major challenge in fuel cell vehicles, which would then finally be solved. One of the problems so far is the complicated manufacturing process. In order to produce the aerogel on a large scale, a more suitable process would have to be developed. Nonetheless, the research team is optimistic. As Duan likewise declares, we are also currently working on extremely lightweight aerogels which could become even more robust, flexible and heat resistant. Wow! The crazy thing is what can be made of this really extreme material. It can revolutionize as much as superconductivity has done and still does, for example. Suddenly, the things that we thought were impossible are now conceivable. But there's one big problem with space travel to another star. Find out what it is by clicking right here. Stay tuned and see you soon.